In today's note, we're going to be continuing to look at acute triangle trigonometry. However, we're done with the sine law and we're going to focus now on the cosine law. So the first example or introduction we want to do is we want to look at this triangle here to our right and we want to ask, can we solve the following triangle? And explain our reasoning. So can we figure out what the two other missing angles are and what the other missing side is? Well, first things first, we are dealing with a triangle. We're looking for sides and angles. Let's check our right angle trigonometry. Looking at this triangle, I don't see any other right angles, or I don't see any right angles at all. I only have one angle, so I can't find any other ones right now. But I don't, to verify this right off the bat, but I don't see any right angles indicated by, again, normally we'd see that kind of square. We don't see any of that, so it's not a right angle triangle, or we're going to assume that it's not. So we can't use our sine, cos, and tan ratios. Secondly, if we now look for sine law, which is the one law that we looked at previously already for acute triangles, I should have a full pair and half a pair if I can solve. So I'm just going to make pairs where they should be, and we'll see if we have any that are full. And in this case, if I look at them, they're all half pairs. They're all missing something. The R pair is missing the side, the P pair is missing an angle, and the Q pair is missing an angle as well. So I can't use sine law to find any of these things. So as it is right now, we're based on SOHCAHTOA, so our right angle trig, and sine law, we cannot solve this triangle. And again, the reasoning for this is there's not enough information. So there's not enough information for us to be able to solve this based on what we already know, or based on what we know so far. And that's where the new law is going to come into play. So there are situations when we're dealing with non-right angle triangles where we can't use the sine law, and that's where we start to use the cosine law. And there are going to be some characteristics to help us identify when we should use the cosine law over the sine law. And again, what we're going to focus specifically on is using the cosine law to find the side length. So, when dealing with acute triangles, if you do not have a full pair and half a pair, we can use the cosine law to solve for missing sides and angles. Now, this may not always be the case, again, depending on what information is given, but if I'm asking you to solve a question or answer a question, and you can't use sine law, then you should be able to use cosine law. Cosine law still deals with the same kind of labeling of the sides and the angles. Capital letters for the angles, lowercase letters for the sides. And we see three different versions of the cosine law. I'm just going to highlight all of them. They are pretty much identical. The only difference is the side that we're looking for relates to the angle that we're trying to find the cosine of. So these are our three different versions for the three different sides in our triangle. But the main thing is this angle, or this side, pairs up with that angle. And then the other two sides that we already have, or that we should already have, are interchanged throughout the equation. And again, it doesn't matter what order or how we label them, because if we see in the first part when we're adding them, it doesn't matter what order we add. And in the second part, we can see that when we multiply them, order doesn't matter when we multiply. So the key thing is, when we're using cosine law to solve for a missing side, the side that we're looking for, we have to have, or should have, the corresponding angle. So the formula generally reads as c squared equals a squared plus b squared minus 2ab times cosine C. And then again, it's the same for the other two versions if we're looking for a different side. So really, you only need to have one formula and just know that you can interchange, or you'd have to swap out the side that you're looking for and the angle that you're given, and then kind of the two remaining sides are going to fill in the rest. But since you have your notes, if you want, you can, again, just refer back to these three formulas. Again, remember the capital letters represent the angles and the lowercase letters represents the sides. In order to solve for a missing side using cosine law, we need to have two sides and a contained angle, or the corresponding angle. And this is basically called side angle side, SAS, or you can call it a sandwiched angle, because the one angle we're given is sandwiched between two sides, and we're trying to find the third one. So we're going to look through a couple examples. I'm going to try one, or work through one, let you try one on your own, then we'll move into a word problem. I'll work through one with you and then let you try one on your own. So using the cosine law, we want to solve for the missing side length. So I am telling you that you have to use cosine law, but you can verify as well. It's not a right angle triangle, and you don't have a full pair and a half pair. What we do have, though, we see a side angle side. So that's what I'm referring to when we talk about side angle side, or a sandwiched angle. This angle right here, angle C, is sandwiched between these two sides. So that's what we're talking about when we talk about a sandwiched angle or side angle side. So the other missing side that I'm looking for is C. It's the only side that I don't have. So I'm going to use the one cosine law formula where it's C squared equals A squared plus B squared minus 2AB times cosine C. Again, if this was you could use the A squared formula if you really wanted to, and again, just swap out or switch the A's and the C's. However you choose to come up with this equation is up to you. But again, the key thing is this side that we're looking for has to be paired up with this angle. And then the other two sides are going to be the A and the B. So once I've picked my formula or written it out, I'm going to fill it in with my given information. So side A is 22, so 22 squared, plus side B, which is 23, so 23 squared, minus 2 times 22 times 23. Again, realistically, you can switch up the A and the B. It doesn't really matter because the order is not going to affect anything. And then we have cosine 73, which is the angle opposite, or the corresponding angle of the side we're looking for, which it is. We can see those two right there. Next thing we're going to do now, all we have to do is go through and solve. The nice thing about the cosine law formula is that the C, or the unknown, is already isolated on the one side. Because this is a long calculation, you could do this all at once. However, I would recommend doing the first part before the subtraction, do that separately, and do the part after the subtraction separately, and then subtract your two answers. Just again to make sure that you avoid any calculation errors. So 22 squared plus 23 squared equals 1013 minus, and if we do 2 times 22 times 23 times cosine 73, we get 295.88. Again, make sure that you have your calculator in degree mode because when we're doing trig. C squared then equals 1013 minus 295.88. we get 717.12. However, we haven't quite finished yet. We've simplified it as much as we can right now. However, I found c squared. I want to find c, so in order to cancel out that squared, I have to square root. So the square root of 717 is 26.8. So that means that c is 26.8. And that's how you use the cosine law to find a missing side length. Before we move on to the next one, just to let you know that today's code word is red. So today's code word is red, as in the color red. So moving back into this, we're going to look at example B now. So again, we do have the side angle side sandwich. So the angle is sandwiched between two sides. So what I want you to do is I recommend pausing the video, try to work through this one on your own, and we'll come back with the final solution for this question. So coming back to this question, we should find that the missing side length is 41. So again, because we're finding side length A, that means the formula, or the cosine law formula that we're going to be using, is a squared equals b squared plus c squared minus 2bc times cosine A. Again, remember that angle A should be paired up with the missing side that we're looking for, and the other two variables are going to be our other two side lengths, or represent our other two side lengths. I've broken it up, so I've solved before the subtraction and I've solved or simplified after the subtraction, just to make it a little bit easier on myself. That way, if I'm going back and double checking my work, I can kind of see where I went wrong rather than trying to do the whole calculation again. Once I simplify that, I need to square root my answer, and when I square root, I should get 41. So the nice thing about cosine law, it's a lot easier to actually go through and calculate it. However, the hardest part is going to be making sure that you have your formula laid out correctly. So in the first example, an ice cream company is designing waffle cones to use for serving frozen yogurt. The cross-section of the design has a bottom angle of 36 degrees. The sides of the cone are 17 centimeters long. Determine the diameter at the top of the cone. So what I'm going to do, I need to figure out this measurement at the top. There are two ways that we could really do this, because we know the two sides are the same. We could figure out what the angles are at the top of my cone if I really wanted to, because of the understanding that it's an isosceles triangle. However, I don't want to really do more work than I have to, so I'm just going to stick with what's given to me. And based on what's given to me, I have a side, angle, side. So I have a sandwiched angle, which means which means I can use cosine law. So because my sides aren't really labeled, I'm just going to use a squared equals b squared plus c squared minus 2ab times cosine A. And because it's not labeled, it might be a little bit tricky to find or label the key information. Oops, and I've already kind of written it wrong as well. Should be 2bc. But again, the key idea is the angle in the cosine pairs up with the side that is unknown, which we do see. We do see that unknown side and that angle are paired up. And B and C are just going to be my two opposite sides, or my two other sides. So if I actually go back and relabel my triangle here, this is A, side A, B and C doesn't really matter when we look at the order and the fact that they're the same number as well. So now I'm going to go through and solve. A squared equals 17 squared plus 17 squared minus 2 times 17 times 17 times cosine of 36, which is my angle. Now that I've plugged everything in, again, I'm going to go through. I'm going to solve or simplify before the subtraction and after the subtraction, just to make it a little bit easier. So a squared equals 17 squared plus 17 squared, 578, and then minus 2 times 17 times 17 times cosine 36 with 467.61. A nice thing to do to check to make sure that we're doing our steps correctly, once we subtract these two, we should not get a negative number because we can't take a square root or the square root of a negative number. So when we subtract, we should not get a negative number. In this case, again, we do not. 110.39. Again, I have to take the square root of that number to get the a value. And I get a final measurement of 10.5. So, therefore, the diameter of the cone is 10.5 centimeters. So that one was a little bit easy because it did give us the triangle. However, for the next example, we're not given any triangle and we're going to have to basically draw this. So in the example, there are 3 boats at sea: Chester 1, Chester 2, and Chester 3. The crew of C1 can see both C2 and C3. The angle between the line of sight to C2 and the line of sight to C3 is 45 degrees. If the distance between C1 and C2 is 2 kilometers, and the distance between C1 and C3 is 4 kilometers, what is the distance between C2 and C3? So there's quite a lot to unpack here just because of the way it's worded. But we're going to highlight a couple things to help you out before you try to solve it. The angle between the line of sight between the 2 boats is 45 degrees. So to help you kind of start off, we have C1, which can see 2 boats, C2 and C3. We know the angle between the line of sight from C1 to C2 and C1 to C3 is 45 degrees. We know the distance between C1 and both boats, and we're looking to see how far apart are C2 and C3. So I've started you off with a little bit of a diagram. Actually, I'll go back in and kind of highlight the other key pieces of information and what we're looking for. So use that to help you finish off the diagram to help plug in the key information. Again, I suggest that you pause the video now to try it on your own, or when we come up to the pause screen, and then we'll come back with the full solutions for this. So again, I do recommend that you try this on your own, challenge yourself a little bit. If you do get stuck, just wait to see what the image looks like and then pause it again, or minimize so you can go back and try the calculations on your own. So coming back to this, we should have somewhat of a diagram similar to what we see over to the right. So I've kind of paired it up color-wise based on what the information we highlighted. So we see the 2 lines of sight from C1 to both boats, and the angle between those lines of sight is 45 degrees. we know that the distance from C1 to C2 is 2 meters, or 2 kilometers, and from C1 to C3 is 4 kilometers. So to figure out the distance between C2 and C3, that's what we're looking for. And because, based off this triangle, we have our side angle side, or our sandwiched angle, we're going to use our cosine law to find that missing side. Again, then when we go through and write out our formula, because it really isn't labeled nicely, I just made it a squared is our side that we're looking for, so that side and that angle have to be paired up, which we do see in our triangle. That angle and that missing side are paired. And then B and C are just going to represent our two other known sides. So again, going through, solving the first part separately, solving the second part separately, just so I make it a little bit easier on myself when I go through and calculate. Square root at the end, we should find that the missing side length is 2.95, or basically C2 and C3 are 2.95 kilometers apart. So again, that's how we can use the cosine law to find a missing side length. Again, make sure you can recognize when we have enough information to use the cosine law. And then again, the hardest part is just probably picking the right formula, or making sure the formula matches the information that's given to us. But again, make sure you can if anything, you can just review, go back through this lesson, go back to the beginning and kind of just double check, make sure that side that we're looking for and that angle that we have are paired up, and then the other two sides are just going to fill out the rest of your equation.